My name is Kelle Dhein. Thank you for being here. I'm assistant professor at the School of Complex Adaptive Systems here at Arizona State University, enrolled member of the Diné tribe. And I'm going to be talking about my work and going through a bunch of projects that are ongoing, incomplete, and at various stages of development. All right, so I'm going to start off by introducing myself, and I'm going to talk about some of my different projects, and if there's time at the end, I'll get into some of my peculiar interests and some provocations to encourage discussion. This is me 10 years ago. I got my PhD here at Arizona State University at the Center for Biology and Society, and I wanted to know, what's the meaning of meaning? But that's too broad a question to do a dissertation on. So I narrowed it down here into what's the meaning of meaning in the context of behavioral experiments aimed at discovering physiological mechanisms. And I feel like I found some clarity in trying to answer that question, but I still want to know more, so that's ongoing. This is a little brief map of my journey after ASU. I was a visiting graduate fellow at the Minnesota Center for Philosophy of Science. Then I was a postdoc at the University of Kentucky, and then I was a postdoc at the Santa Fe Institute before coming back here and starting in August, this last August 2024. And now my office is right here in this building where the people who are in person are sitting. It's all nearby here in the ECA. And my research at this point basically has two main areas. One is the history and philosophy of science. That's what I've been doing the longest. And then the other one is research relevant to Indigenous data sovereignty. And I'll get into sort of what that is later on in the talk. And the way I see it, the sort of connecting tissue between these two areas of my research right now, it's methodological, and it's me using the same methodology to clarify the meanings of complex concepts. So I'm going to start out with the history, some history and philosophy of science stuff I have going on before moving on to the Indigenous data sovereignty stuff. So last semester, I collaborated with Pedro Marquez Zacharias and Max Stressow on sort of coming up with something to submit to this event that was happening at the Minnesota Center for Philosophy of Science called Philosophy of Science, Past, Present, Future. And you can see that the call was asking for people to reflect on the current state of philosophy of science and its history while setting an agenda for future research. So I got thinking about sort of philosophy of science, history and philosophy of science, and what's been happening, where's it going, and where do I see myself in that story? So just a little brief background here for people. History of science and philosophy of science can be separate things. There's departments that are just history of science. There's centers like the Minnesota Center for Philosophy of Science. They're just doing philosophy of science, at least nominally. And what's the basic difference between these two sort of areas of inquiry? Historians of science tend to make narrative arguments about why science happened the way it did, and they're much more likely than philosophers to bring in contextual factors, like a scientist's biography, their life history, how that influenced the kind of science they did, the technology that was available to them, politics, economics, culture, place, tradition, all as sort of influential factors shaping science. Philosophers of science traditionally are into reconstructing the logic of scientific practices, scientific theories, and scientific explanations, and then assessing those theories, practices, and explanations according to sort of logical norms. Sometimes they bring philosophy problems to science. So for instance, a classic philosophy question is, what is the truth? What's reality? And they'll sort of take these questions that have a long tradition within the Western philosophical canon, bring them to science, and sort of come up with arguments about like, well, what does it mean to say that science is getting at reality or that it generates true statements? And then sometimes they bring science to philosophy problems. So for instance, philosophers have been trying to figure out what consciousness is for a long time. And some philosophers of science will say, recent work in neuroscience, for instance, is probably relevant to this long-standing philosophical question. And so they'll try to bring empirical evidence from science to bear on the philosophical questions. And I'm someone who believe, I do both of them. I like doing both of them. And I believe to do a good job at one, you're going to have to engage in the other to some degree. So I'm like an integrated history and philosophy of science guy. And so in thinking about the history and philosophy of science, I was looking at sort of different trends that have happened historically over the last 200 years or so. And I came up with this spectrum across which you can categorize some things happening. And one end of the spectrum is the stance that scientists and philosophers are basically indistinguishable, like doing the same kinds of stuff. And then on the other end of the spectrum is this view that philosophy is separate of or outside of biology. Don't let them touch each other. They're totally different things. And so there's some different styles or movements and where they fit on this spectrum, in my opinion. About biological philosophy, I'm talking about a continental European tradition, maybe people like Schelling, where they are looking at sort of developments in the life sciences. They're thinking about the theory of evolution and natural selection, and they're like, what does this mean for man's place in the universe? Like that kind of philosophizing. And then there's historical epistemology. This is like a mainly French tradition. They're looking at scientific concepts. And they still see, like we're different than the scientists we're looking at, but it's not quite as separated as at the other end. Philosophy of biology, I would say, that's what's happening in most places today. It comes from an Anglo-analytic tradition. They're closer to seeing themselves as interacting with scientists and working on problems that matter to scientists. And then at the far end, the early 20th century organicists and theoretical biologists who saw themselves as scientists, but were also saying a lot of very abstract, theoretical, very philosophical things. And that's where I see myself on the spectrum currently, the kind of history and philosophy of science I'm doing. And then I started thinking it'd be nice to get some kind of empirical evidence to bear on this question of what is going on in the history and philosophy of science as a discipline. And so I thought, how would I do that? And here was the entryway I picked, a professional academic society called ampersand HPS, stands for Integrated History and Philosophy of Science. So it's a bunch of people who, like me, think you've got to be doing both at the same time to do either well. And they're a pretty new organization. They had their first meeting in 2007, and they meet once every other year. So they're coming up on their 10th meeting here sometime this spring. And what I did is I collected and read every abstract for every presentation that's happened in the first 7 meetings. I wanted to do them all, but I severely underestimated how long this would take. And also had trouble getting all of the abstracts. They're not all just out there on the internet, so I'm hounding people to send me things. But I can present some of the results from analyzing the first 7 meetings of Integrated HPS. And so one of the things I did is I came up with a coding system where after reading a bunch of them, I thought about what are the main things people are doing in these presentations, or at least claim to be doing, since I didn't watch the presentations themselves, just the abstract describing them. And this is a list of things I came up with. So one presentation can do multiple things simultaneously. So like programmatic meta history and philosophy of science. These are presentations where there's like making arguments about how you should do the history and philosophy of science. Or a sort of H for P case, standing for history for philosophy case. This is using a historical case study from some time in the history of science and using it to justify more general philosophical claims, usually about how science works. So they're like, this is how this kind of scientist does things. Look, here's a case that shows it. And these 3 are the most popular things that historians and philosophers of science are doing. P for H concept, it's mostly like a historical narrative argument, but the narrative focuses on abstract philosophical concepts. So it's sort of like telling the history of a concept. And then P for H big was popular. This is sort of like history of science is important. Whatever topic they're working on is just important for its own sake. And what this really represents in the literature is like the fascination with big figures in science. So like Isaac Newton, for instance. No one feels the need to justify getting into the extreme minutia of anything Isaac Newton ever did, because it's just assumed that it's going to be important because it's Newton. And so there's a lot of history and philosophy of science that falls into that kind of category.
Hey, Kelly,
Yeah,
what's philosophical cleanup?
philosophical cleanup is that there's some episode in the history of science which is sort of widely regarded as confusing or messy. People like don't know what's at stake or what's even going on, and then the philosopher comes in and is like, I'm gonna clean up this situation. I'm gonna draw a bunch of distinctions and say this was this was that, and you know, they may not solve the problem, but they'll at least be like, here's at least a framework for thinking clearly about what happened in this episode, because everyone's using, you know, often the same word maybe in different ways across a whole bunch of different disciplines that study science, like a sociologist of science, a historian of science, philosophers trying to step back and be like, here's the once and for all way of thinking about what was happening in this moment. And I haven't had a chance to turn these into graphs yet, but this is just the numbers on it for different meetings. Like I said, one presentation can do multiple things. And you know, when I think about myself and what I'm up to, this is basically what I do as a historian philosopher of science. The philosophical cleanup, Paul was just asking about new historical evidence. I like to go into the archives, find something that people have never talked about before, and then use it as evidence in some kind of argument. I like telling the history of concepts. And you know, I'm very sort of anxious that the things I do matter to scientists. I think that that's important. And so an example is this paper that I wrote. It does all the things highlighted there. That's the style of HPS it is. And I'm very happy that it's my most cited paper, and almost all the citations are from insect navigation experimentalists. So it did make contact with the scientists predominantly. So when are HPSers thinking about? What sort of span of dates within the history of science? These are graphs that are specific to each meeting. I also compiled them into one where you can see general trends. You can see that you know, the 20th century, by far the most popular time to be thinking about science. And that's basically true for me too. I fall into this trend, but I'm trying to expand on both ends. I'm trying to get closer to the present, but I'm also trying to push back into the late 1800s right now in my research. What sciences are HPSers thinking about? So again, one presentation could be about multiple disciplines. And the first thing to note here is that the x-axis is logarithmic. So, you know, it looks like physics is ahead, but it's actually really, really far ahead. There's like the complete domination of physics in integrated HPS. Biology is next with half as many. And then after, you know, physics, biology, chemistry, Newton, just the person is the next most popular thing. So that's what I mean about like why the, what was it, P for H big category is so popular. And you know, complexity not on there, doesn't appear, but I'm going to change that. I'm doing history and philosophy of complex system science. And so one of the projects I have going on in this area is asking the question, what happened to cybernetics? So it's one of the sort of forerunner disciplines, I would say, of complex system science, and there is consensus around that. People agree. It's also a sort of forerunner to today, what we're calling dynamical systems theory or control theory. And it sort of really made its first splash in the public with this book, Manifesto, published, I believe, in 1948 by the American mathematician Norbert Wiener, Cybernetics or Control and Communication in the Animal and Machine. And you can see by the subtitle that it had sort of vaunting ambitions from the start. So it's a study of vital importance to psychologists, physiologists, mathematicians, psychiatrists, etc. So cybernetics made a lot of promises for a lot of different areas of science, but within the behavioral sciences, which are what I like to think about, one of the big promises they made was that they were going to use newly formalized notions of information, feedback, and control to create a general, maybe universal theory of behavior that would apply just as well to humans, animals, and machines, any kind of behavioral system. And so this is a sort of run through I like to go through just to emphasize the contested nature of cybernetics within the history of science. So this is a encyclopedia entry from the USSR, 1956. It says cybernetics is a reactionary pseudoscience arising in the USA after the Second World War and receiving wide dissemination in other capitalistic countries. Here, this is a sort of quote from one of Kennedy's top aides that he wrote to the president. It says, based on CIA reports, in October 1962, President Kennedy's top aide wrote in an internal memo that, quote, the all-out Soviet commitment to cybernetics would give the Soviets a tremendous advantage. He warned that by 1970, the USSR may have a radically new production technology, managed by closed-loop feedback control, employing self-teaching computers. If the American negligence of cybernetics continues, he concluded, we're finished. So this is probably familiar to a lot of us right now. China and AI, for instance, repeating itself, history repeating itself here. Also, we have Salvador Allende's government in Chile, socialist government. He creates something called CyberSyn. It's this room, and it's supposed to be a sort of central planning and control zone for the economy. And so it's supposed to be hooked up to factories to keep track of production, stores to keep track of demand, and to keep all of this equal. And it was largely created by this crazy English guy named Stafford Beer. He was a cybernetician, and he consulted for Allende's government. And he got into a fight with some sort of US government officials in print. And one of the things he says to them is, perhaps it's intolerable to sit in Washington, D.C., and to realize that someone else got there first in a Marxist country on a shoestring. As to the horror of putting computers to work in the service of the people, I would sooner do it than calculate overkill, spy on a citizen's creditworthiness, or teach children some brand of rectitude. CyberSyn was destroyed in the next regime change in Chile. Here we have a continental philosopher, Ponte, from the phenomenological tradition. He says, in the ideology of cybernetics, human creations are derived from a natural information process, itself conceived on the model of human machines. If this kind of thinking were to extend its reign to man in history, if we were to set out to construct man in history on the basis of a few abstract indices, then since man really becomes the manipulandum he takes himself to be, we enter into a cultural regimen where there is neither truth nor falsity concerning man in history, into a sleep or a nightmare from which there is no awakening. And here we have a television show from the 80s called The Greatest Thinkers. They did one episode on cybernetics and Norbert Wiener. It's like I don't have, oh, it's just loading still. I also don't have audio. That's all right. They don't say that much specifically, except it's going to be a really big deal for the future. They use the phrase complex systems in the episode. Where'd my cursor go? I'll skip the next one, clip from here too, but the host just concludes the episode by saying, cybernetics and complex system science is the next step in human evolution. Here's a historian and philosopher of science more recently from 2010, also looking at cybernetics. He says that it stood out in the history of science because it pursued a non-modern ontology that rejected the people-things dualism and the detour through representational knowledge. The English documentarian Adam Curtis has a documentary series called All Watched Over by Machines of Loving Grace, where he looks at cybernetics. Says that this is the story of the rise of the dream of the self-organizing system and the strange machine fantasy of nature that underpins it. And then there are even more recent papers talking about cybernetics leading to sort of neoliberal capitalism. And so to sum up here, depending on who you ask and when you ask them, cybernetics was something that was going to produce a universal theory of behavior. It was capitalist pseudoscience. It was an engine of socialist economic planning, a dehumanizing nightmare, the next step in human evolution, missed opportunity for a new way of doing science, strange machine fantasy that warped our view of nature, harbinger of the rise of the neoliberal technocrats. And so I bring up this list here because I think that these many perspectives could also be sort of leveled against complex system science today, and that depending on who you ask, people might have these opinions of complex system science. And that's no coincidence, because it's coming out of the cybernetics movement. But if you ask most academics today, and they've heard of cybernetics, they're likely to say that it's a failed movement and that it's dead. Nevertheless, many complexity scientists continue to see the concept of information as sort of harboring revolutionary potential in the behavioral sciences, and that it can help us solve big problems revolving around behavior and decision-making. So I'm on the case trying to find my own answer to, what was cybernetics? What did it mean? Why does it matter to us today as complex systems people? And the basic framework that I use when I do this, that I'm also going to be bringing to my other work in Indigenous Data Sovereignty, is that scientists do science, scientists make claims, people use the claims to guide their future action, and the connective tissue between these steps is interpretation, justification. Right? Whatever the scientist does is supposed to justify their claims, and for those claims to be able to guide action, they need to be interpreted. And I focus on these connecting tissues to make sense of everything else going on in science. And another way to show this is, here's a framework. This is like capturing the way I think about science. It's a research program developing over time. There's an initial state of doubt. Scientists design an investigation to produce evidence that will ameliorate that state of doubt. Sometimes they're successful, and the results of their investigations, they say, justify a new belief. The new belief is targeted at the initial state of doubt. And then once they have this new belief, it guides their future research in new ways, and causes them to have new doubts, and the process continues on. And so this belief fixation, new belief formation stage is usually the only stage that's publicly accessible to people, because scientists make claims in research articles, or they go to conferences and they give presentations. And so that's the sort of handhold I usually use to grab hold of a problem in the history and philosophy of science. But then I try to get at everything surrounding that claim to make sense of the concepts that were in the claim. All right, and so as I said, it's iterative, the process keeps going. There's multiple research programs happening at any given time, so they're running in parallel. And the claims of one research program can influence the future research actions of another research program community. And the reason it can do that is because these scientists are existing in a sort of interpretive cloud with each other. They've received similar training, they have similar implicit assumptions, and so they're able to read the research reports of their peers, and it gives them new ideas for research in a way that it wouldn't for other people. So for instance, like if my uncle read a research paper, he's gonna have very different ideas about how to guide his future action than someone who's working in that same scientific discipline. And I like telling big picture narratives about these interpretive clouds, these traditions, by focusing on the minutia of experiments. These are some of the favorite concepts I've been thinking about within the context of the history and philosophy of complex approaches to behavior. Behavior, motivation, instinct, information, cognition, they may seem sort of straightforward, or like you may say, well, I know what those concepts mean, but I think you don't really know what those concepts mean. And so just for motivation and instinct, here's a recent publication I've come out at the end of last year that deals with both of these concepts in the behavioral sciences. And just a point about why any of this matters. So scientists, they're not born scientists, they become scientists. And before they were scientists, they were part of a whole bunch of other communities and cultures. All right, and so there's this reciprocal relationship between broader society and popular culture and scientific research communities. The ideas from one area inevitably filter through to the other and then back again. So the example I usually use for this is that at one point, the idea of dopamine as an important neurotransmitter for feeling good or having pleasure, that was just some technical sort of niche thing happening in a laboratory somewhere. And today, the language of dopamine is pervasive in the culture. And so that's how scientific work on behavior colors how we think about ourselves, how we think about others. So scientific concepts that promise to control and predict behavior concern everyone, I argue, because they're bound to re-enter society and color the way we deal with ourselves and others. All right, so that was a little taste of the history and philosophy side of the research that's going on right now. I'm going to switch over to Indigenous Data Sovereignty, Ethics and Policy. How did I even get into this area of research? Happened in 2001 when I became a consulting bioethicist for the Native Biodata Consortium. It's the first nonprofit biobank and research institution led by Indigenous scientists and sort of intellectuals. And it's located on the sovereign land of the Cheyenne River Sioux. That's also a first for an Indigenous biobank, just to be located on sovereign Indigenous land anywhere in the United States. It's never happened before. So they put me on all kinds of projects since then. And one of the projects I was working with Morona Vinali and Fernando Fisher. And they said, well, what would it look like if you could try to wipe away sort of like Western assumptions and philosophies and come up with a white paper on how to do Indigenous genomics research that was based on Indigenous philosophies and cosmologies from the beginning. And that was a hard problem to think about. It sort of put me on this direction I'm at now where, so I'm already a guy who clarifies complex concepts. That's what I've been trained how to do. That's what I like doing for my historian and philosopher of science side. And so I'm bringing that over into the context of Indigenous data sovereignty. I'm thinking about concepts like data. For instance, how does something become data? It has a lot of philosophical implications to that question. What determines the meaning of a datum? Sovereignty, another sort of complex concept. Rights, human rights, are sort of invoked everywhere in the Indigenous data sovereignty literature. So I started looking into the history of this idea, thinking how useful is it for the goals of Indigenous data sovereignty. And so if I have time, I'm just going to get into, I have projects going on all three of these concepts right now. I'm just going to try to get into the data and the sovereignty ones. So data. The stage of this project is that there's a paper that's under review. And so what I sort of note in this paper is that proponents of Indigenous data sovereignty, they say that the concept of data is contested, it's value-laden, it's philosophically complex, without ever really engaging with what an IDS sort of view of data should look like. So they'll say things like, the concept of data is imbued with a host of meanings within and across contexts. To some, it is simply information, while for others, it is the very pulse of a revolution. Or the idea of data is a broad concept, but in the context of this chapter, we define data as information that may be recorded in various forms. Right? And so from the sort of philosophical perspective of trying to answer questions like this, which I believe are sort of central to any philosophical account of data, defining data in terms of information doesn't really get you anywhere because information has the same philosophical ambiguities as data. It's also, what's the difference between information and not information? What makes information about anything? These continue to be philosophically mysterious questions. And so what I want to go through is two different views that sort of offer answers to those two central questions about what data is and what determines its meaning. And so here's the first one. It's one that I don't like and I argue against in the paper, called the correspondence view. It says data are reflections or snapshots that straightforwardly represent some aspect of the world. So I have a camera and a mirror here because that's the analogy. That data are like little mirrors or little photographs out there, and they just like represent some aspect of it. All right, and so it's pretty clear that it's this correspondence relationship, whatever it is, that determines the meaning of data. And sometimes to articulate what this correspondence relationship is, people draw on mathematical ideas like homomorphism or isomorphism, where they just say things like, it preserves the structure of the world somehow. And that's why the data is about this aspect of the world and not that other aspect. And so when you think about data in this way, it leads you to ask questions like, is our camera, our mirror, our recording device is it good enough to accurately represent the way the world really is? Are we clever enough to interpret these reflections and representations? And so on the correspondence view, the sort of two main areas for failure are that scientists are using faulty measuring devices or that they're stupid. Like if they're smart and they have good measuring devices, then we're off to the races and we're going to be learning things about the world. The other view of data coming out of the pragmatic tradition, let's call it the pragmatic way, that is something I endorse. And I think that it's a good view of data for realizing the ends of Indigenous data sovereignty. It says things only become data when someone uses them as evidence to support claims or actions. So I'm drawing on the work here of another philosopher of science, Sabina Leonelli. And what this view of data does is it reintroduces human agency into the picture. Causes you to ask questions like, what do we want to accomplish by quote unquote representing the world via data? What sorts of claims are we trying to justify? What relations are created by using something's data? All right, so on the correspondence view, sort of like scientists are innocent passengers being carried along a line of inquiry by the facts. In the pragmatic one, we foreground scientists' agency, intentions, and values in the scientific process. And so I got three reasons why I think that this pragmatic view of data is the best for Indigenous data sovereignty. First reason, it gives a better perspective on the future trajectory of science, which is important for Indigenous data sovereignty, because I should step back, I guess. I never said what that is or defined it loosely even. It's a pretty recent, I would call it intellectual political movement. And the basic idea behind it is that Indigenous peoples, in their history of interactions with colonial forces, there's a similar story that plays out, that Indigenous peoples have something that's valuable. It gets extracted by outside colonial forces, and the Indigenous people don't get anything in return and sometimes are hurt in return, right? So a lot of people are saying that, the next thing where this is going to happen is data. That data is like the new oil, it's the new gold, and there's going to be a data rush on Indigenous peoples, and they aren't going to get anything in return to improve their material conditions. And the Indigenous data sovereignty movement sort of saying we need to leverage this notion of sovereignty, the idea that Indigenous peoples, at least in the United States, have some version of sovereignty to make sure that we benefit from the value of our data. All right, and so how does the pragmatic view of data lead to a different view of the trajectory of science? This is just a sort of, rinky-dink network graph thing. It doesn't actually represent anything right now, but the basic idea behind this is that the nodes are discoveries and they're connected by edges to other discoveries, because in the process of science, discoveries make new discoveries possible. And on the correspondence view, you have this view of science progressing where all the data is already out there with human independent meanings. It's sort of like a scavenger hunt view of science. And scientists are in the process of discovering those meanings. So the nodes are sort of waiting out there for scientists to connect the dots. The pragmatic view of data, there's a lot more contingency because you have to take into account the sort of things scientists value, because the things scientists value determine what they're willing to call a problem, what means they're going to use to try and solve the problem, and then what they're willing to accept as a solution to that problem. So there's just way more nodes all of a sudden because there's way more variables basically in what's happening in a given scientific investigation. And when you think about scientific progress in this way, it leads you to ask questions like, well, how many problems could people possibly solve using the same data? And this is just speculative, but I think humanity's capacity for generating problems and accepting solutions is infinite. So the problems that could be addressed are infinite, and so the meanings of data are infinite. But the main point here is that science could have progressed differently, and the pragmatic view of data really underscores that contingency. It can still progress differently. And the Indigenous data sovereignty movement needs institutions that can bend scientific progress towards its own goals. And another way of saying that is that they need institutions that are going to support a tradition of biological inquiry that's guided by Indigenous values and concerns when it comes to these moments of identifying problems, picking methods, and accepting solutions. And the Native Biodata Consortium is such an institution. As a biobank, they preserve data for future use. They create and enforce rules about who can use the data, and they selectively facilitate the use of that data. So another way of saying that under the pragmatic view here is that they're investing in the future meanings of data, which are unknown, because we don't know what uses people will come up with for them. They're controlling the current meanings of data by controlling how they're used now. And then another question that comes up here is, well, how ought they control current uses of data? And this is the second way that I think the pragmatic view of data is going to help Indigenous data sovereignty. It provides a more penetrating vision of science that's fit for Indigenous judgment. When, for instance, if you're the Native Biodata Consortium and you have to make a decision, oh, this group wants to use this data for this purpose. Thumbs up or thumbs down, to put it in a very simplified way. So here's an example that I made up so it would be clean, but it's very similar to things that have actually happened. We got a plant varietal here with drought-resistant traits found only on sovereign Indigenous lands. The outsider scientists, and they want to study the plant, right, for this trait. So they're going to need to extract this biodata off the Indigenous community's land. And what narrative is the scientist going to use to justify that extraction to their funders, to the Indigenous community, to themselves? Let's say something, I'm trying to understand the genetic basis of drought-resistant traits. Why? To help solve problems of global warming, right? There could be famine in the future with global warming, and understanding the genetics behind drought resistance in agricultural crops could be really important for feeding people and preventing famines in the future. And so these twin goals are sort of like forever being claimed by scientists. They want to understand the world and they want to improve the world. You might say something here like, it just happens to be the case that this plant on Indigenous lands is part of the solution to a humanity-wide problem. I wish it wasn't like this, everything's messed up, but this is the situation we're in now. And the Indigenous community is put in a situation where it's like you can either stand in the way of progress that's going to help everyone, or you can be selfish, like not let someone study this plant. All right, but when you take the pragmatic view of data, it sort of changes this phrasing. You're forced to say, well, I want to use this plant on Indigenous lands as part of the solution to a humanity-wide problem. And that I want opens the door to a series of further questionings that puncture the veil of these generically virtuous goals. So I'm not arguing here that scientists are dishonest about wanting to understand the world and improve the world, but these are just sort of too vague to really be inputs for good decision-making about whether a scientist should be able to do something with data. So for instance, I think understanding is a fake goal. And to see how it's a fake goal, just think about, how will you answer a question about how do we know when the thing is understood? How will the scientists demonstrate that they've achieved their goal of understanding? And the answer to this question is always going to come down, in my opinion, to the scientist's ability to do something relevant to the thing they're trying to understand. Right? So in this case with the plant, it's probably something like the scientists can claim they understand the genetic basis of drought-resistant traits when they're able to manipulate that trait by manipulating something about sort of the genetics of plants. And that's an actual specific goal, right? It's not just I'm trying to understand the world. Now we're talking about things the scientist is actually trying to do. Similar for improving the world, you start to think, well, what's it actually within a scientist's power to do? So they don't legislate trade agreements, they don't marshal the forces of industrial agriculture, they don't control supply chains. So to say that they have this goal of stopping famines in the future, it's sort of like a tire manufacturer saying they have the goal of building a luxury automobile. It's like what you do might be necessary for that, but it's far from sufficient. So third reason, this is the shortest one here. I think that the pragmatic view of data is more in line with certain, at least North American indigenous philosophies. And insofar as indigenous data sovereignty is about indigenous peoples using their own ways of knowing, their own cosmologies to inform the way they control the use of their data, I think it's important to try to get at that somehow, which was the project that originally put me on this path, remember, was trying to come up with this white paper that's based on indigenous philosophy. And I haven't explored this that much yet, but the basic idea here is just that the pragmatic way of thinking about data really emphasizes relationships. And so does a lot of indigenous philosophy, especially when it comes to the task of defining things, which is always very important to philosophers. And so indigenous philosophies that I've been looking at in Southwest of America are often going to define things in terms of its relationship to other things. So for instance, I have the medicine wheel here because that's often used as a visual metaphor for this way of thinking. But to be a person, it depends on your relationship to things like other people, the place you're in, your own thoughts, your own body. And you can contrast that with a more traditional Western way of defining things. You got Aristotle here as a representative of it. And that's of defining something in terms of necessary and sufficient properties or conditions for the realization of that thing. And so on this way of defining things, things possess properties. And so to be a person, you have to be a kind of thing that possesses certain essential properties, such as maybe rational thought, being 5 people. I don't know, different people come up with different lists. All right, so that's the end of the data one. What about this concept of sovereignty? This one is even newer in the developmental stage of research. I'm just trying to write some grant proposal about it right now. I'm going to be collaborating with Trevor Reed. He's a law professor here at Arizona State University, a member of the Hopi tribe, has a PhD in ethnomusicology, as well as a JD focusing on federal Indian law. And all of that's relevant to the way that I want to get at this question of what would it mean to clarify indigenous notions of sovereignty? So just some notes here to foreground this problem. Sovereignty, it's not just one concept. There's many different concepts of sovereignty just within the Western European political tradition. And these concepts don't stand alone. They sort of travel in packs with related ideas like views of human nature, views of nationhood, views of human rights, ideas of individual and collective freedom. And so different sovereignty concepts support different visions for how humanity ought to organize itself and make decisions as a corporate entity. And the question I'm asking and pursuing here is, well, how do we clarify indigenous conceptions of sovereignty? And there's really, some major philosophical problems sort of waiting to jump out at anyone, just even within the way I'm phrasing this research aim. And so one of the big problems is just a general issue of comparing concepts. So here we got 2 things, not concepts. We got a screw and a banana, and we can compare them because we can characterize them in terms that sort of apply to both, that are appropriate for both. So like hardness, okay, how hard is the banana? How hard is the screw? The idea of hardness, the operations we perform to assess hardness are the connecting bridge that make the comparison between a screw and a banana possible. Same with something like taste, color, etc. But there's no consensus way to characterize concepts. Different philosophical traditions have radically different ways of doing this. And so as a result, it's unclear how to compare concepts. For instance, the concept of a screw and the concept of a banana. Because the concept of a banana isn't yellow, it doesn't taste like a banana, right? It doesn't have these sort of properties that would make comparison possible. And my solution to this problem right now is that I believe that every concept has a pragmatic dimension, which is a way of saying that all across time and space, people use concepts to do things for reasons. I think that's general enough to apply. I'm not making too many prior assumptions when I say something like that. And so the different variables and factors surrounding a person using a concept to do a thing for a reason can provide the sort of connective bridge that will make comparison possible.
So this is my visual example, try to get at this right now. Like we can compare these things via the framework of problems and uses, because in this case, they can both be used to attach two pieces of wood. And so we can start to talk about, oh, this one's better than that one in terms of attaching two pieces of wood or because it attaches them in this way. And so with this problem I'm trying to get at, indigenous conceptions of sovereignty, we have the issue that, like right from the outset, sovereignty is a Western concept. And so you don't want to assume that there's going to be some concept in indigenous philosophies and cosmologies that corresponds to sovereignty in a straightforward way. And this pragmatic dimension of concept solution helps us get around this issue because we can reframe it. It's no longer a research program about indigenous conceptions of sovereignty. It's about this problem or use frame of reference of how to organize human collectives, which again, I think is a problem that's universal across time and space with our species, that we live in groups. Figuring out how to do that isn't obvious. And so I think any group of people is gonna have developed conceptual tools for confronting this issue of how do we organize ourselves and make collective decisions. And so then the question is, within the indigenous philosophy cosmology, what set of concepts have been developed for addressing this problem? And then furthermore, I think it's super useful when two different philosophical conceptual systems come into conflict. And I know this through my work as a historian and philosopher of science, that scientific debates are some of the most enlightening episodes for philosophers and historians, because scientists are forced to sort of make their assumptions more explicit, and they attack each other's weak points, and they emphasize their own strengths. And so it's sort of like opening a window into the conceptual workings of science that usually remains closed. And I want to take advantage of conflict in the same way with this project. So, whereas a lot of times with a project like this, people would endeavor to get rid of all colonial influence to try to recover like an untouched philosophical state in indigenous peoples. I'm trying to sort of flip that on its head and leverage what I was just talking about with conflict between systems, as well as the well-documented text-based nature of legal conflicts. So I'm going to use legal conflicts as the sort of handhold to grab onto, just like I use scientific claims from research reports as the initial thing I grab onto. And then I look at everything surrounding that to make sense of what was happening there. And so I think, indigenous peoples had concepts that they used to address the problem of how to organize themselves, how to make collective decisions prior to contact. And no doubt those influences were present in the way that indigenous peoples sort of made arguments in the Western court context, which were often about sovereignty and ownership of property. And then I want to look at sort of how the different ways they confront these concepts play out historically. I'm still working on the details of this. I just put this here so you can see the sort of connection here and how I'm trying to bring the methodology from the history and philosophy of science into this new area. All right, so I just got 10 minutes. I'll zoom through this and it's short. These are just peculiar interests, provocations. I like Adobe building. I would like to incorporate that into my work eventually somehow. I like hydraulic models of neurophysiology. I think it's a really interesting way of thinking about brains and behavior. It still invokes this idea of a representation, but it does it in a non-digital computer way, which is the norm currently, I think. To think about like discrete variables that computers have, or a circuit board. These are more like analog computers. And I like when scientists use this model of thinking when they investigate brains and behavior. I like puppets. I was once making a online series of classes about the history and philosophy of animal behavior research. I was using puppets, but I underestimated how long it would take me to write the scripts and just get all the resources together. Like I had voice actors with the puppets, but I'm teaching a new class next semester here, history and philosophy of complex system science. And maybe I'll find a way to get the puppets involved. Into New Mexican fences, there's something going on here. Huge amount of variety and diversity, more than I've seen in any other state in the US, and it's not just poverty, which I think a lot of people probably jump to, that they're just using whatever materials are at hand. Very interesting part. I got a whole collection of photos of New Mexico fences. And then something I've been doing lately, just ending my presentations with a list of provocations to get the audience going and asking some questions. So I'll read them off. Instinct concepts are unfairly maligned. Learning's overhyped. Brains are not obviously just computers manipulating symbols. Cognitive revolution sort of constrain the scientific imagination just as much as it enables new pathways for investigation. I think meaning is determined by use. Probably know what I mean by that now, since I keep endorsing pragmatic approaches to problems of meaning. As a result of adopting the pragmatic view, I think desire, purpose, and drive are the most mysterious ingredients of meaning. I think correspondence theories of truth are European mysticism. Behavior is the only solid foundation for theorizing about brains and minds. Human rights are fake and insidiously undermining the Indigenous Data Sovereignty movement. I can get into that in this presentation. And the trajectory of scientific progress is extremely contingent, more so than is commonly appreciated.
I don't think that last one's a provocation.
Thank you.